Well, good morning, everybody. I know somewhere in this beautiful world you're having a wonderful day, I hope. And today, again, I have my good friend Keith Bromley. Now, I've known Keith for many years, and Keith is what I call the resident expert on packet brokers. Uh, Visibility is so key today in our networks, Keith, and many people have packet brokers, and many people don't use them.
Yes.
And that's a problem. So, what do you see in that world, Keith?
Yeah, people make an investment in a packet broker, and they just don't seem to get the value out of it. They just let it sit there. It's too complicated. It's something something something, and it's like you're throwing away one of your best assets out there. When you're looking for security problems, troubleshooting issues, performance problems, first off, you need to collect the right data. Collect data, then you need to get the right data from that. So you need to go through a filter, deduplicate, whatever, and then you send that information onto your security and your performance monitoring tools. But you've got to get the data and you've got to do something with it. If you just take all that data, you stick a tap in your network and you just send all that data straight to your tool, it's like drinking from a water main. Stick your face down in there and you've got this massive flow of data just hitting you, and quite a bit of it is irrelevant. It's not something that's going to be pertinent to what you're going to use for troubleshooting or performance or whatever. So you need a packet broker or something like it that will do the filtering, deduplication, and cut basically that massive amount of data down to the right size.
Well, a packet broker is an essential tool today, but also one thing is get a packet broker that you can operate. Some packet brokers require line code. Some packet brokers have a translator. It's a line code translator, which is often not that smart of a translator. And then, of course, there's a real GUI system. I know a NUI that is Ixia Keysight now. They have a real GUI, and I've used it. And I've written line code before, and I've actually made many mistakes. And I bring up the article I wrote several years ago that after 38,000 reads, nobody sent me an email and said, there ain't no way in heck that line code you wrote would even work to begin with. Yeah. So it is complex, but it shouldn't be complex. And also something else about packet brokers that we always forget. It's a great visualization tool to help you know your network. And next year, we're going to be doing a series on how a packet broker can help you know your network. So we're going to be doing a series on that. Keith will be involved in that. But today, Keith wants to talk about some special things. So what we're going to do is I'm going to share my screen here, and we're going to talk to some of his slides here. So Keith, go ahead and let's just talk about these.
Okay. Yeah, so what I thought we'd do is, like you said, there's two things that I think are part of the problem with people using some of the packet brokers. The first is the interface, but like you said, that's really been solved, especially with the unit we've got from Ixia, where it's a visual drag and drop, point and click. You literally, if you want to start a connection of data flow, you draw from an input port a line over to a filter. It's that simple. And you double click on the filter and you just select the parameters, which are real simple click settings as far as what you want to filter on, and maybe if you want to type in an IP address or range of IPs and so forth. But other than that, it's really simple now compared to the CLI. What the second part is, well, how do you really use it? I think that's what some of the people are getting confused on now. So, like with this diagram and the next one we'll show you in a minute here, just wanted to point out there's two basic use case types, right? So the first one is out of band. And what we mean by out of band is that the network packet broker and the monitoring tools are not in the flow of the network data. So you can see down there, that's what the tap is. The network tap, it is in the flow of data, but it's a one-time hit. You install it, and that's it. After that, it makes a copy of the data that goes up to the packet broker, which then goes on to the data goes onto the tools. So it's a one-time hit for your network. After that, you've got access to all the data you need across your network with these different taps, and you can filter and deduplicate and so forth. So this is the out-of-band use case. And then the next one is inline. So now in this use case, the packet broker and the tools are in line. As you can see from the left, the data goes from the firewall to the bypass switch, and then it goes up into the packet broker and into the tools. So if the packet broker if the packet broker filters data there or does something with the data, that will affect what passes on downstream. But as far as the inspection process, it helps you send the right data over to the right tool. If you want to do decryption and so forth, you want to daisy chain tools from an IPS to a WAF or something like that, you can do it very easily with the packet broker.
But this is a common application. Most people want an out of band, right?
It depends. So yeah, I would say there's probably more out of band if you want to do deep packet inspection, Wireshark, and so forth. But you know, a lot of companies now are really putting in inline security tools, the IPS, the WAF, decryption, because you almost have to. There's up to 70% of malware is encrypted now.
Yep.
So if you want to stop the malware, you're going to have to decrypt it. And especially with TLS 1.3 now, you have to do active decryption man in the middle. So you're going to go to this inline use case.
Yep. Yeah, that's an interesting part there, and very few people use it in a thought process like that.
Yeah. Okay, so those are the two basic use cases, and then what I thought, use case categories. So what I thought here is, well, why don't we just look at maybe some pictorial representations of some use cases, because one of the fundamental things, the benefits that you're going to get from the out of band scenario, and you can see where on this one I put down their deployment scenarios out of band, is process improvement. If you look at the left side over there, this is just a generic figure, but if you follow it, you know, you've got some sort of trouble alert, you go investigate, you open a ticket, you got to capture data, configure your tools on your crash card, and then get permission from a change board to go and actually insert those tools into the network and then debug and so forth. There's a lot of time, a lot of wasted energy, and a lot of delay in the meantime to repair with that type of process. Once you do the tap and the packet broker type of process, you look on the right side. Well, the tap's already installed, so you don't need a change board approval to go do that. It's already there. Same thing with the packet broker. It's connected up. Even if it wasn't, you can go connect it to the tap because it's not going to affect the flow of data into the network. So you can connect whatever tools you want at will when you want, without any regard for almost any regard for the change board approval process, because you're not going to affect any of the data flowing on the network. You're just going to take that copy that's coming from the tap and manipulate it and do what you want with it to get the data you need for your Wireshark tool to go investigate problems, or your APM, NPM tool, whatever it is you're trying to figure out.
Security onion or whatever, yeah.
Exactly. So literally what I showed here on the right is you're cutting half your processes or more in half. Again, it's a simple visual, but it's really representative of how much of a benefit you get just because you have the packet broker in there anymore. You don't have to go and get your crash cart. You don't have to go configure, hopefully, your tools. You definitely don't have to move the tools around on a crash cart. Right. You've got the data access you need right now. And from an ICSI point of view, we have literally seen several customers that have a mean time to repair that was reduced by up to 80% just by putting in the packet broker and this type of process. Because some of the change board approvals, you think, well, okay, so I go request that. Well, you may not get access for a week or 2 weeks to get to go fix the problem. And then you're going to be limited to your probably 2 or 3 hour maintenance window. Yep. Whereas with this process, hey, I could go do this at 9 a.m., 10 a.m.
Well, that's one of the key reasons that I always tell people when they're building their infrastructure, put a tap in. No more negotiations for access. And one of the big things today is being able to prove to the authorities that the bad guys didn't exfiltrate all your data. They only exfiltrated a little bit or half of it or whatever. And that could save your company millions of dollars. But the wrong time to think about that is when something's happening. It's too late. And meantime to recognition of an event is critical today. Okay.
Yes.
It could be something simple, or it can be a breach. And as you pointed out earlier, 80% of malware today is encrypted.
Yeah. Yeah, and it's only going to get worse, you know.
Yeah, it's only going to get worse. And TLS 1.3 didn't solve our problems. It may have given us a few extra ones, but it did help a little bit. But there's back at Network General days, back in 94, 95, when we had the first tap built and for Ethernet, it was almost like people bought a sniffer and they bought a tap. But they bought the tap to move it around because there weren't change processes, permission processes, and that back in the 90s. Okay, it was, I call it the Wild Wild West internet days. But today, if you don't have a tap, you've just automatically expanded your mean time to recognition, not to mention your mean time to resolution.
Yes.
And I would hate to go to my boss and say, gee, we had a network downtime for 8 days, and problem was it took me a week to get permission to even get in the network, see what was wrong.
Exactly.
Well,
and that's the whole purpose of this. You know?
Right. Yep. So
that's one example. This one is a second one. So what happens is, depending upon how you've got your network laid out, you're probably going to get lots of duplicate data for your security and monitoring tools, especially if you use taps, or if you've got a Cisco ACI architecture with all the BiDi taps and stuff in there. You've got lots of duplicate copies of the data. You need to get rid of that. If you send that on to your security and monitoring tools, they've literally got to go through and wade through all of the bad data to get to the good data before they can actually start processing. And with security tools, that can actually be a big problem, because when the security tool sees multiple instances of this bad data, it's going to spin up more and more processes in the CPU to go and look at this incident, and it turns out that 3 of the 5 incidences may be the same incident, but it's going to spin up 5 different processes here to go and look at that. And so you really want to get rid of all of that garbage, that extra data, the monitoring data. Again, so this is out of band, this is not inline.
That's right.
And when you do that, we've actually seen customers that get a 30 to 50% process improvement there, because they're getting rid of that much data. And you can get that, if you put a tap in normal operation, if you put a tap at the ingress and several other points across your network, you can actually make multiple copies of data by accident as well. You'll get different types of data as well. But then, like I said, especially with Cisco architecture, ACI architectures now, you are going to get a lot of duplicate data. You really want this thing just to go in there and deduplicate. And the great thing is, it's a turn-on feature. Yep. It's not something you have to go and program in depth. It's just you go turn it on.
Well, one of the things one of the things I always tell people, dedupes or filtering is great, but make sure first that you really don't have multiple or duplicate path, because that's going to cause you problems. And if your tool is filtering that out, you'll never know that you've got that problem. So always make sure up front that you don't have duplicate paths or multiple paths, and that way you'll know that when the dedupe is on, that you're getting the real data. It's not hiding anything. Now, this is out of band, but in band is when you get into that problem.
Yeah. Yeah. Okay. So that's another simple example of something you can do. Here's a third one that's really just like a benefit. So with the Ixia packet brokers, like I said, on the left, you're going to have the incoming data or incoming data port there on that port. In the middle, you can see what we call as a dynamic filter, and that's our filter in the middle. And then on the right are the tool ports. So those are the ports connected to your Wireshark, your APM, NPM, IDS, whatever. So one of the cool things, though, that you can do with with our packet broker is if you look at the bottom there, there's a filter in the middle, and there's a tool port on the right, but there's nothing on there's no connection on the left. There's no little line drawn from that incoming port over to the middle filter. What that is we call it a floating filter. It's basically a pre-stage filter connected to a tool. So it could be Wireshark or something for diagnostic purposes. It's all set to go, all connected up, but there's no incoming data stream to it. So once you get this configured, which could take you several minutes, after that, if you want to do some sort of investigation, some APM or Wireshark investigation for troubleshooting, literally all you have to do is go over to your incoming data port and draw a line over to that filter, and you're going to start the flow of data to the filter and and start filtering data to the tool. And so what happens here is if you need to start troubleshooting with this filter and tool preset, you literally, it's going to take you less than 1 minute to go and draw that line over there. You can start troubleshooting in a minute or less. That is one of the fundamental things here where, again, I said you get this dramatic reduction in the amount of time between the data you have and some sort of analysis. This is one of the reasons why you can pre-stage this and then just start your troubleshooting a minute, 2 minutes later. Somebody calls and says, hey, I've got a problem. You know, draw a line over from a port to the filter and then start analyzing right away.
I have a friend that works for a major pharmaceutical company, and what he did is he made up these laminate pages, and it says, you know, if the question is or the problem is this, attach filter 3 to your ingress, okay, and then your output goes to, you know, whatever, Snort, Snoop, whatever, Wireshark, Security Onion, and then it tells the technician to look for certain things. Mm-hmm. Okay, but he's got it on laminate cards right at the interface, and they just, oh, you know, Joe says that the servers are slow. Let me see what okay, here's what I do, and it gives them even examples of timing and what he should be seeing, what he shouldn't be seeing, and he said it's increased. Well, first off, he said it's helped the young people that don't really know how to do all this yet. Okay. He says, so they can do a quick response till we get our real team in there. But he said, even our real team uses it now because it makes it so simple. They know what they should be seeing when they connect the filter up. And, you know.
Yeah, that is clearly a best practice. That is exactly how you want to do it.
Well, you know, your book that you got that Ixia has on different filters you can set up in your packet broker. I think that's what started him thinking about that. And he's got Ixia, the packet brokers in 4 or 5 places in his network, and every one has got these laminate cards, 8.5 by 11, with the perspective of that where that is in the network.
Mm-hmm. Yeah. Again, that's exactly how I would do it. You know, you set up these filters you need and with the tools, and then just set up your process to go along right with this, and it just makes it so much simple, easy. Especially like you said, if you've got some junior personnel that, but you want them to start working and troubleshooting and debugging things and whatever before level 2 or level 3 tech gets involved. This is how you do it.
Yep. But I thought that was a really cool application.
It is. Yeah. That, like I said, that's a best practice for sure.
Isn't it?
So here's another example, number 4. So one of the things that you can do with a packet broker that's pretty much just simple and easy is you can take off the headers if you don't need it. You can and then you can either save the header, or you can get and get rid of the payload, or you can get rid of the header and save the payload. There's different use cases around the data depending on what you want to do. If you're just looking for some basic information from the headers, or if you're still looking for information that's in the packet payload. But the packet broker just makes this quick and simple and easy. And again, from for Cisco ACI, VXLAN, if you're using that, this is an easy way to go through and strip off some of the routing headers and stuff like that you just don't need. And more importantly, that your monitoring tool may just not understand. You put these extra headers on there and stuff, and it may confuse some of the older tools, especially. And I don't know what your opinion is. Maybe even some of the new tools still don't process the headers that well, or just strip them off. But this is another fundamental use case.
Yeah, but always remember, if you're using the VLAN or if you're using the span port, remember they are delimited, and you want to make sure you know what kind of delimitation there is. Don't ever think you're getting everything from all of those. It'll kill you, and you won't know it's killing you.
And so here's another a use case. Again, this one's out of band. So one of the cool things, with the data centers the way they are, especially, I think pretty much everything is a hybrid, like public or private cloud, along with still physical on-premise equipment. To some degree, there's some that are pure cloud environments, but a lot of what I'm seeing out there is there's still this hybrid environment where some things are better done in the cloud, some things are better done on-premise with physical on-premise equipment and so forth. The great thing about the packet brokers is that you can combine the data from both sets. So maybe you got some cloud data that you want to send to security and monitoring tools. You can actually take and export that with like some sort of cloud tap or virtual tap for the cloud. Or if you've got a virtual environment, virtual data center, so VMware, something like that, KVM, you can take that data, export it through like a GRE tunnel or something, and send it over to the packet broker. And then the packet broker can find that with data from your physical data center, and then send that collected set of data to the different security and monitoring tools. Especially if you've got like compliance initiatives, this gives you a complete view of your network. So your virtual and your physical on-prem environment, you can combine the data, the monitoring data that you need to get a complete view. Makes a lot of the decisions and the validation for, like I said, compliance purposes a lot easier and a lot better. You've got all the data you need in one spot.
Right, and you can delineate what information you're going to see at tap 1, tap 2, tap 3, span port 1, span port 2. Like that guy wrote on his cards, you can have that knowing that tap number 1, you're going to see this type of information. This is what you're going to be able to troubleshoot. And you can do that throughout your network, including VTAPs and span even.
Yeah, and so I showed span here as well. You're right. So there's tap, there's span data, and then over on the far right, I showed like a little virtual tap connected to some sort of public cloud or private cloud service that you've got going on.
Yeah, and I'm going to mention here, one thing I see a lot of are white boxes coming out of China, and people claim that they're American-made, or they claim that they are fully aggregate, and I haven't found but one or two, one being Ixia, and one being another one, where they actually are able to pass all the data. You don't want to think it's a tap and find out that it's very much like a span port. So you want to make sure they're real taps. Buy them from a credible vendor who's been tested. And by the way, I think next year, isn't it, Keith, that the U.S. government is requiring vendors to provide proof that they can hash their software, hash their firmware, and that they can account for every chip in the device. And I think it's also in there that you can't have a device that has all of the chip information erased from it. But that's something coming up, I hope, within the next year or so.
Yeah, if it isn't, it needs to be.
Yes. Oh, here you go.
So here's another example. Now this one is an example with an ACI architecture. So I've already, mentioned a little bit, but with the BiDi taps, the leaf spine structure for an ACI architecture, you're just going to get duplicate data packets. There's no way around it.
Yep.
And especially if these taps are running at 40 gig or 100 gig in your network there for the spines and so forth, that's a massive amount of duplicate data. If you take that, send that straight on to your security monitoring tool, I'm pretty sure you're just going to blow it away. 40 gigs of that is a lot of data. And then when you find out that 30, 50% or more of it's just a waste of duplicate data, that's a massive amount of tools you're going to need to process that data. And in fact, there was one customer we had that was one of the business cases they looked at. And it's like, oh yeah, so I'm going to have this much data. I've got to go, and they dimensioned out how many monitoring tools, I forget the specific type of tool, but monitoring tools they were going to need. And then we went and talked to them and said, well, if you put this packet broker in, you're going to get rid of this amount of the data. And it literally cut their tool costs down dramatically. And even though tool costs have come down over the last 5-10 years here, it's still a massive amount of data. So you want to get rid of that. And then you've got the ER span encapsulation issues. You've got, like I said, the VXLAN headers and so forth. And the great thing is the packet broker just gets rid of a lot of that stuff for you.
It makes it a lot easier to revisualize your data.
Yep.
And by the way, one of the points, I'm sorry, before you start this, is packet brokers are not meant just to be used when there's problems. You can use a packet broker when everything's running fine to really understand your network. So don't think it's just a diagnostic tool for the emergencies. It's also a tool where you can learn about your network and maybe find flaws long before they become issues.
Yeah, exactly. And I've we got a couple more use cases here, and they're probably, like you said, more for, well, this one's not really for a problem. This one's for saving cost here, but some of them are focused on problems. But there's an ebook that we put together at Ixia that's got like 67 different use cases for a packet broker, and several of them are to help you with your network and better dimension it. Like I mentioned deduplication earlier, and it was really to get rid of the duplicate packets. In one use case that we're not going to, I don't have a diagram here to show it. In the Ixia packet broker, you can actually do the exact opposite. You can look and see, well, how much duplicate data is in the network, and natively, and is that good or bad? Is that because based upon the amount of duplicate traffic and where it's coming from, you can actually use that to better dimension where you place your taps and how many taps you put in your network, you don't put in your network. So it can actually be a useful tool for dimensioning and so forth.
Absolutely.
Anyway, so here then, those were pretty much 6 use cases out of band. Here's this one's could be inline or out of band. It's be very common for an inline, and I think we talked about this in our last podcast, where you can use the packet broker for load balancing. So on the left side here, I show 40 gig input coming in, and then 5 8 gig tools. So there's your 40 gigs on the right hand side. That's normal operation. Well, if one of them fails, if you have bandwidth available on those tools, that they can go up to 10 gigs each on the tool, then you could go through and even though you've lost one of the tools, you can still process the full load. The data is just redistributed across the remaining 4 tools instead of 5. And what will happen here is the packet broker can do that automatically. You're going to take the data, and then you're going to assign it to a port group, and then assign these different tools to different ports within that port group. So that if one of the ports goes down, the data coming into that port group still gets split across the remaining 4 tools in this case. So it gives you a very easy way of doing load balancing, and N+1 reliability. You don't need to do any load balancers. You don't need to buy extra equipment. You don't really need to do any additional programming after you set it up for the first time. Again, just assigning the ports and the data to the port group and so forth. It takes care of it itself. And then there's a little heartbeat message from the packet broker over to the different tools. So when the tool comes back up and it's functioning again, the packet broker is going to automatically start sending data right back over to that tool. So it's got this self-healing mechanism built within it as well.
That's very cool.
Yeah, it's simple, it's easy, and it's a great way to give you some redundancy at a very cost-effective price point.
In general speaking, how long, when someone gets a packet broker, how long would you say it normally takes them to get it hooked up the right way? To is it an experimental process, or is it pretty easy for people to pick it up pretty quickly?
It's easy. With the Ixia packet broker, for sure it's easy. We literally have customers that are up and running within 30 minutes or less.
Oh, wow. Okay.
And it's like I said, it's all in the interface is intuitive. It's drag and drop. One of the previous slides back there showed the interface with the port group on the left, the dynamic filter in the middle, and the port group on the right. You literally just say, hey, create a filter, and then when it pops up, you double click on it, you set the parameters, and click OK. And then when you want to start or take away service, you can just like draw a line from the incoming port to the filter, and from the filter over to the outgoing port, and boom, it starts working. So
yeah, it's a very cool GUI. I've used it before.
Yeah. And then so here's our last example. So this is SSL decryption. Again, this one showing inline now. And with the packet broker there, it's showing built-in SSL decryption, which makes it quick, simple, easy. It's all within the packet broker. You don't have to send the data out anywhere. It will decrypt the data, and then it can send it on to your IPS or other tools. An alternate configuration is where you come into the packet broker, and then you could go over to a special purpose-built SSL decryption appliance, bring the data back to the packet broker, and then have the data sent on to an IPS, WAF, UTM, whatever type of security appliance you want to put there. So it doesn't have to be where you use the internal decryption, but it's makes it a little simpler. You don't have to go set up that external appliance. You don't have to go constantly apply fixes and updates to that external appliance. This is all part of the packet broker, so the maintenance is easier doing it this way. But either of those two use cases is definitely better than doing like decryption within the IPS or the other security tools, because for one thing, you're going to get a significant performance hit, and that's what I mentioned there at the bottom of the slide, is that just to turn the decryption feature on for some of these IPSs and WAFs and so forth, you're going to take at least a 20, probably a 40% performance hit on your CPU, because it's got to go do all this decryption functionality that it really wasn't intended for. It's intended to go and process the datas and look for threats, and you've got to siphon off those CPU cycles to do something else. So it may sound interesting. Hey, I'll just turn on decryption within my tool here, but most of the customers we've run into, when they do that, the performance problem is so bad that they end up turning it off, and they've just wasted buying the feature on their tool.
Now the Ixia supports 1.2 and 1.3, right?
Yeah, we support everything. 1.1, 1.2, 1.3 for TLS SSL. That's
good. Yeah, because don't forget 1.4 will be coming soon from your local store.
Yeah, that's the thing about security, right? It's never-ending change and updates and so forth. But
that's right.
It's a game. And the thing, though, is the packet broker makes the game easier for you. Right now, so much of this is slanted in favor of the hackers and so forth, where they only have to be right 1% of the time.
Right.
It's like, we talk about, you can have your security architecture perfect 99% of the time, but that 1% is still a complete failure. So you've got to constantly adapt to make it easy.
That's what catches you off guard. That
Yeah.
1%. And also, like I keep saying, a packet broker is not just about fighting fires and diagnostics. It's also about learning your network, and it can be very cool. I mean, I had one guy call me and say what he did is he programmed one of his ports just to watch the addresses inside of his network, and if all of a sudden he saw an aberrant address, okay, he got an alert and it started recording what that address was doing. Well, it actually happened that a vendor had come in and had somehow gotten in their network, and his computer wasn't protected, had some viruses on it, and it was trying to give them to everybody in the network. So, it's oops, but that's a big oops. He goes home and you got the infection, and but it's so easy to learn. As a matter of fact, one of the things that on Network Datapedia, we're going to be next year having a series of articles about how to use your packet broker to know your network. And Keith's going to be part of that, and Excel, and it's going to be real interesting because we got some pretty good experts out there like Tony Fortunato and Mike Pinocchi, Chris Greer, Paul Alford. These guys do it every day, and of course they know networks so well they don't have to worry about small minutia. But I don't believe every network manager out there is at that level. And this is going to be really fun to learn some of the things you can do. So when something happens, you're a little bit ahead of the game. Mm-hmm. So we talked about all these cool applications for packet brokers. There's so many really neat things you can do. And if you want to reach out to Keith, and in the article that's on the Network Datapedia about this quick webinar we did today, it actually gives you the link to a book, their book, on the many things you can do with a packet broker, and it's certainly worth printing out, and if nothing else, put it in your rest place. So when you're not doing anything, you can read it. It's worth every bit of it. Trust me.
Yep. Yeah. We think it's a good asset, and there's several other assets too in that article. So check the article out for other tools.
And by the way, Keith has written, I don't even know how many articles and webinars on Network Datapedia and Love My Tool before this. We're the same website. We just modernized and moved over. Well, Keith, any other exciting points you want to come up with, and other than pay and pray? Or it's not pay and pray anymore. It's play and learn.
Yeah. No, I mean, I think we pretty much covered it. It's like you've got the packet broker, just start using it. And even if all you do is just connect it to the tap, do that. You've got so much flexibility. You can connect your Wireshark, your Snort, whatever to that, and just play with it a little bit. And you're going to see it makes things so much easier. You just got to start. And there's so many simple use cases you can do before you ever get to complicated extra other ones. There's so many simple ones. Just start playing with it.
Yeah, there is so much. It's so easy to play with. By the way, if I can do it, you guys can do it. Trust me, anybody can. Okay. So, well, listen, Keith. Thanks again. This is great. People, just remember, visibility is the essential key to protecting, growing your network. Okay. If you don't have visibility, you are doomed. So think about it when you're putting in new links and lines and switches and routers. Put in a tap in those places where you need visibility. It'll save you a bunch of hair pulling, and you won't have to pray to get someone to let you have access or make a change. So trust me, it's worth every bit of it. And the big companies are learning it. They're starting to do it. I know for a long time, taps were considered the last thought. We don't need to see that, but now you do, buddies. Trust me. And so, Keith, thank you so much, man. It's been great. And I wish everybody out there, great networking. Enjoy it. Don't fight it. Learn about it, and you won't have to fight it. Keith, thanks again. I appreciate it. Hope we see you again soon.
Yeah.
All right. Take care, everybody. God bless all.